Welcome to Circuit Fix. Today I've got this antenna from Betso. It's a LPDA, but the special thing about it, it's got an amplifier inside, and it also has an attenuator, so you can actually boost the signal going to your other equipment coming from the antenna, or you can attenuate it to cut down on noise to help the front end on your radios when you're receiving. The customer states that there's no RF coming out of here, so let's hook it up to the signal analyzer and see what we see. I've got a radio turned on in the room at about 655.6 megahertz or so. And without the antenna connected, you can see it's coming in on the analyzer at about negative 65 dB. I'll plug in the antenna and see what happens. So we have a small improvement at negative 56 dB or so. That's with the antenna set to 0. Let's try to change the gain on the antenna and see if we see any change on the analyzer. That should be jumping way up, and we're still around negative 55, negative 60. So not a whole lot going on with the amplifier and this antenna. So let's crack this thing up and see what's going on with it. I've never taken one of these apart before, but it looks like we have about 6 T10 screws holding this on. Let's remove these first. And they're rather long screws. Now let's flip this back over. I need to be really careful because I'm sure that there's some sort of thin cables that are connecting everything on the inside of here to the actual antenna. I don't really see anything obvious. All right. Really careful. Okay. The antenna is connected. With one of those connectors. It popped right off, no problem. There's a little gasket there to protect all this stuff in the inside from all the rain and moisture that these will get exposed to in the field. Seat that down properly again so it'll stay. Now we've removed the business part of the antenna. Let's put this into the microscope and have a quick visual inspection. This is some factory flux. I don't see anything burned yet. Do you guys? Alright, nothing jumps out at me right here. No. Our equipment plugs in here, and that goes to the radio, the receiver radio. That goes to the actual antenna, so this is the input, this is the output. The bias voltage to power everything is going to come through here, but that's working. So we need to look for what's attenuating. So we know this microcontroller is probably working since the readout works and you can change all the levels. The menu works. There's got to be a chip on here that probably does the attenuation. And I don't see anything else on here except for this chip here. Let's see, it's a what is that? MCL DS50. Let's look that up. I've identified this chip as a mini circuits digital step attenuator at 50 ohms. And let's see if we can find the pinout. Here we are. Make sure none of our voltage inputs are shorted. That would be on 6 and pin 9. And 6. Not shorted. Pin 9. Not shorted to ground. Alright, let's see if we have voltage. pin 6. We got 3 volts there. And we have 3 volts there. So the chip's getting power. Now that we know this chip is getting power, the next thing we need to check is to make sure that it's passing RF. I set it to 0 before I took the unit apart. So technically the RF on the input should be the same as the RF on the output, and it should not be attenuating. It should at least be passing signal to the RF out. So let's check that. Pin 1 is the RF input and pin 14 is the RF out. So let's check on the analyzer to make sure we have RF on both of those. And coming in on pin number 2, looks like we've got about a negative 52 or so signal coming in on pin number 2, which is about what it was doing before, right? So pin number 14 is RF out. That would be about here. And again, somewhere in the neighborhood of negative 57 or so. So I believe the attenuator is fine. The amplifier is not amplifying before the attenuators. So far we've determined that this is the attenuator chip from many circuits. Let's try to find our amplifier. Let's look for the amplifier IC. And if I had to guess, it's probably this chip right here. 504 it says. So let me see if I can figure out what this is. So I think I found it. This is a Mini Circuits 5043. It's a monolithic RF amplifier. And here's our pin out. So we should have RF out on pin 1 and RF in on pin 3 and ground on the other 2 pins. So this RF chip has ground on pins 2 and pins 4. The DC power comes in on pin 1, and that's the RF output. And the RF input is on pin 3. So let's measure our RF input on pin 3. And it's somewhere in the neighborhood of negative 65 dB coming in with no antenna hooked up. And on the output we have just a little bit higher, about negative 57 dB coming out. So I believe that should be amplifying a whole lot more than that. So I'll go ahead and order one of these chips, and with the magic of YouTube, I'll be right back. So it's been a few days and the chip has come in the mail, and it definitely looks to be the same one. I don't want to lose it. If I can get it out of here. Come on, little guy. All right. There's not really anything on the circuit board behind this or anything I can really damage. If I work quickly with the hot air, I should be able to take this off and replace it without causing any issues. I'm just going to come in with a little bit of flux and some hot air. And I've got the old chip off. Oops. All right, nice fresh solder for the pads. Now we can come in with our hot air again and deliver the new chip. And that should do nicely. Let's come in and clean this up. A little isopropyl alcohol. Now that I've got the new RF chip installed and I've got everything buttoned back up, it's time to start testing. I've been using this Betso Octopus. It takes 12 volts in and it'll send 12 volts out as bias power, and also it'll take 2 antenna inputs and it'll send 4 outputs for each antenna, which is nice. So I'll go ahead and plug this in. If we look at the signal analyzer, we can see that currently this is picking up somewhere around negative 50 dB. And if we plug it in, that jumps up to around 0 dB. So that's a really good RF signal coming in off the antenna now. Now for one final test, I'm going to bring it over to some real-world equipment that we might use this antenna with. I've got a transmitter turned on, 474.3 megahertz. And now I'm going to connect the antenna. And what a difference that makes. So the antenna is definitely working nicely. So it looks like we've actually repaired this LPDA Betso Sharkie antenna. Thanks for watching, and we'll see you next time. Circuit fixed.